Hello again, Tom here from Every Step Calculus, everystepphysics.com. I wanted to do two videos on this section of line integrals dealing with I and J, and so let's do it. Index 8 to get to my menu. Scroll down here now to line integrals. This was submitted in Yahoo from a problem from this kid here, so I thought I'd do it for him and you. Line integrals, here we go here. Alright, press enter. And what do we have? We have I and J here. So that's number 6. I and J, okay? Notice this menu. This is all of the line integrals that I know about from tests, and it will solve all of them step by step. These are not easy. They're also pathetic because to me they're a complete waste of time. Don't solve anything for any purpose at all. And they always come up with one number, and they don't even put units beside the number. They just have the number there, which I'll show you when we get done finishing this problem. So we're going to choose number 6, I and J, in the program. Very good. And notice that this system in Calculus 2, because we're in I and J yet, in Calculus 3 it'd probably be I, J, and K, And here we have M in front of the I and N in front of the J. Okay, that's the terms that we're going to be dealing with here. This is M, and this is N. Okay, so let's do it. We're going to enter the M function term before the I. Okay, so we're going to enter this one here. Now you're going to press alpha first. For instance, you're going to go alpha 2 times y squared, and press enter. Okay, now we're going to enter the N function term before the J, which is x. Okay, but I've already done that to save time, so I've entered these in the simulator here for the save time. And of course, if you entered them, you could always say that change it in case you made a mistake. I say it's okay. Our line segments given. The other one, remember, was no line segments. It was dealing with IJ that they gave you in the problem. This one, they give you the line segments, 8, 4, x and y, to the other point, x and y of 0, 0. So we say yes, and we enter the x, y, and x2, y2 points, okay, that they give you, which is 8, 4, and 0, 0. Again, I've already entered those into here, save time, so here we are, 8, 4 to 0, 0, okay? We can change that if we wanted to, but I say it's okay. And then whenever you parameterize, you have a formula, okay? That's 1 minus t times x1 plus x2 times t. Well, x1 is 8 and x2 is 0. Okay, so then you multiply this out. 8 times 1 is 8, and 8 times a minus t is minus 8t. And here's the answer here, okay? Y is the same thing. The formula for y is the same thing, okay? Now when you parameterize, the range becomes 0 and 1 for t, okay? So now we have to do the derivative, of course. X is equal to 8 minus 8t, and the derivative of that is minus 8. And y is 4 minus 4t, and the derivative of y is dy, which is minus 4 dt. The original integral now in this situation changes to dx and dy because we found the derivative for those, and that's the system. So you mark this stuff exactly like you see on your paper, okay, to get 100% of this problem. And we've done that. let's see, and we enter the what we've solved for x and y. Here's x, 4 minus 4t, or 2 times 4 minus 4t. Now that's y here. You're entering it, okay? Notice how confusing it is. And then the dx here is minus 8 dt, okay? And what is this? Is x. So here's x, 8 minus 8t. Now I have quotation marks here. You're going to put parentheses around that so you look like a real mathematician, okay? The calculator does this and I can't change it. So you're going to put parentheses around these quotation marks here. 4 minus 4t has quotation marks around. Parentheses around the 4 minus 4t here. And the 8 minus 8t, okay? Sometimes we have to think in calculus in college, so I'm expecting you to do that and understand this stuff, okay? And we multiply it out and condense it. Here's the answer. We mark this on our paper, just like that. We integrate it. Now I know you could integrate this like nothing, couldn't you? Of course you could, without the program. I couldn't, so I needed the program. And over the range of 0, 1. At t equals 1, the answer is minus 16. Notice we're substituting t1 for all the t's in the problem, okay? And then at 0, we're entering 0 for all the t's in the integral that we found, okay? Upper minus lower is minus 16. Minus 256 divided by 3 equals minus 304 over 3. Easy problem, huh? We just solved this kid's problem, and you solved it in a test or homework. Remember, my programs do all this step by step for these type of programs and 1,000 other programs. Notice this answer here again is, physics professors and all these people into calculus think that these make you believe that this solves something, that this is some sort of an electron area that went across the surface and whatever they dream up. But no units beside this. So what is this, jock straps, or what is it, coffee cups? Minus 304 divided by 3, is it meters? Is it feet? What is it? Squares? Cubics? What is it? So calculus is a lot of baloney, that's for sure. Hey, go to my site, buy my programs for 40 bucks. They're well worth the price. You're going to never, ever be upset that you paid that money for these programs, let me tell you, because it helps you so much in calculus. So go to my site, buy my programs and pass calculus. Have a good one.